We need to prove that the length of the angle bisector AD in this triangle is given by this expression. Now, this result is actually interesting and it might be useful to remember it. So, we are being asked to prove that the length AD is given by this expression 2bc over b plus c times cos alpha. Now this quantity itself 2bc over b plus c is called the harmonic mean. So an angle bisector of A is the harmonic mean of the sides C and B times the cosine of that angle alpha. So either this angle or that angle. Now, in order to prove this, we will use law of sines. But before we go into that, there is a theorem that we need to know. It's called the angle bisector theorem. What it says is an angle bisector in a triangle splits the opposite side in the ratio of the closest sides. So the angle bisector, AD is the angle bisector, which means these two angles are equal, and it's going to split the opposite side BC in some ratio. And what is that ratio going to be? So the ratio of these sections BD to DC is the same as the ratio of the closest sides. The side closest to BD is C and the side closest to DC is B. So BD over DC equals C over B. Now this is what we are going to use, and what we will do is we will find the length of this section BD in terms of BC. And notice all of BC is denoted by the letter A. So that's one other thing that was not given in the triangle, but we can write it down. And notice that the angle A of the original triangle is 2 alpha. So we'll use some double angle formula as well. So let's go ahead and use the angle bisector theorem. Write down BD to DC is given by C over B, which means we want to find BD. So BD, let's go ahead and cross multiply first. B times BD equals C times DC. And also, now I want to find BD, which means I want to eliminate DC. I'm going to use the fact that BD plus DC is A. So let's go ahead and solve for DC first. So DC is, you divide both sides by C. So B over C times BD. All right. And now we know that BD plus DC is A. And we will plug DC. So this, we have BD plus DC is given in terms of BD, which is B over C times BD. This is equal to A. And we can, BD is the common factor. We can remove that. Then it would be 1 plus B over C is equal to A. And we can simplify on the left side inside the parentheses. I will have BD times C plus B over C is equal to A, or let's write down BD is, you multiply by the reciprocal of that, is going to be AC divided by C plus B. So you multiply both sides by the reciprocal C over C plus B. So this is what we are going to use. BD is AC over C plus B. So let's go ahead and redraw the triangle. And this time we will label BD. So our original triangle, ABC. Then let's go ahead and draw the angle bisector. That was D. Each of these angles was alpha. This is denoted by C, this is denoted by B, and BD was AC over C plus B. So let's write that down. AC over C plus B, or yes, C plus B. All right, so now we can apply law of sines to this triangle ABD. So from the law of sines, we know that if I take this side length BD, which is AC over C plus B, and I divide by the opposite angle, sine alpha, this is going to be C divided by, or let's take, let's use this side, L. So not C, but L over the opposite angle is sine B in that triangle. So this is one relationship. Let's cross multiply. AC over C plus B times sine B is equal to L sine alpha. All right, the goal is to find L. Now, so B is not known, and then I have sine alpha here and sine B there. But notice A sine B happens to be equal to B sine A. And how do we know that? Because A over sine A is B over sine B. So if you cross multiply, you get this. A sine B equals B sine A. And it's useful to think. If you have an expression like A sine B, you can change it to B sine A, or C sine B could be changed to B sine C, depending on what we want. What I wanted is, I don't want B here, but I would rather have angle A because it involves alpha. In fact, A is 2 alpha, like we said earlier. So let's rewrite the left side. So what happens on the left side? The numerator C, I did not change that, but A sine B, I want to write as B sine A over C plus B is equal to L sine alpha. So this equation is being rewritten with A sine B replaced by B sine A. Now, what is sine A? A is 2 alpha. So A is 2 alpha, which means the left side is really CB times sine of 2 alpha over C plus B. And the right side is L sine alpha. Now, what is sine 2 alpha? From the double angle identity, we know sine 2 alpha is 2 times sine alpha times cos alpha over C plus B equals sine alpha. Now you can see that there's a common factor of sine alpha on both sides. You can cancel that. It's like dividing both sides by sine alpha, and we obtain the required result. L is what? CB times 2, I can write that as 2BC. So let me write B and then C over C plus B, let's write as B plus C, cos alpha. So that's our answer. That's the proof. And like I said, this quantity 2BC over B plus C is called the harmonic mean of B and C. So you can remember length of the angle bisector of A is the harmonic mean of these two sides that form the angle A at times cosine of half of that angle A, or alpha.